Hello friends, this video limits and derivative part 18 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 17. Please make a note, this is a crucial form. Let's prove this theorem. This theorem we use very often in the last lecture also we have used this, that f of x is equal to x to the power n, then f dash of x is equal to n x to the power n minus 1. Very crucial formula. Let's derive this. That is, if fx is equal to x to the power n, then f dash x is n x to the power. Correct? Let's prove this. So we know that f dash of x is nothing but f of x plus h minus f of x by h. Correct? F of x plus h is nothing but x plus h to the power n minus x to the power n by h. Obviously h tends to 0. Limit of h tends to 0. So we have to find the value of this. So we can expand this using binomial theorem. We know that x plus h to the power n is equal to n c naught x to the power n x to the power 0 plus nc1 x to the power n minus 1 x to the power 1. The value of x will decrease, power of x will decrease and h will increase, plus nc2 x to the power n minus 2 x to the power 2 dot ncn x to the power n and x to the power 0. This is the value. Correct? Now from this we subtract, right, minus x to the power n. We will say minus x to the power. So this is nothing but x to the power n, x to the power 0 is 1, x to the power n, and nc naught is also 1. So this part and this part is, see, you can cancel this. So this part is equal to this, and here we can take h common because everything is h common. This becomes nc1 x to the power n minus 1 plus nc2 x to the power n minus 2h plus dot ncn x to the power n minus 1. This is the value. So we will replace this value here. So what the function we get here is nothing but h by nc1 x to the power n minus 1 plus nc2 x to the power n minus 2h dot ncn x to the power n minus 1 by h. H is cancelled. And we say limit h tends to 0. Now we will put h is equal to 0. What will happen? All this will become 0. All the numbers which has h multiplication. So this will be equal to nothing but nc1 into x to the power n minus 1. nc1 is nothing but n. This is nothing but n x to the power n minus 1. And that is how. What we have done, we have just used the formula of f dash x equal to f of x plus h minus f of x by h, and then we expanded this using binomial theorem, and then we have got this value of f dash of x is nothing but n x to the power n minus 1. Please remember this formula. It's a very useful formula. We will be using this formula. To take an example, we have this function an xn a n minus 1 x to the power n minus 1 a n minus 2 x to the power n minus 2 till n on. We have to find the value of f dash x. So here we know that if f of x is equal to x to the power n, f dash x is nothing but n x to the power n minus 1. Correct? We know this formula. So we use this f dash x to be an is nothing but constant. So we leave this an constant into x to the power n will become n into x to the power n minus 1. This is first part. Not plus second part an minus 1 is constant, so we can leave this plus this x to the power n minus 1, this will become n minus 1 into x to the power n minus 2, because here n is equal to n minus 1. So n minus 1 will become n minus 2. N minus 1, you will multiply with this n minus 1 and you will reduce the power. That's what we are doing. If it is to the power n, we put this n here, you see this n will be there, and we reduce the power. So we have put this n minus 1 here and we reduce the power. Plus, let's do for this, then I think without a bit clear, plus a n minus 2. Here what we will do, a n minus 2 is a constant, so we have put this, plus x to the power n minus 2. So we will put n minus 2 here, multiply this, and reduce the power. So this becomes n minus 2 into x to the power n minus 3, correct? Plus a1 into x to the power 1. X to the power 1 will become 1 into x to the power 0. 1 minus 0, plus constant. For any constant, if you differentiate, you get 0. This becomes 0, correct? You get here is an into n x to the power n minus 1 plus an minus 1 into n minus 1 to the power x n minus 2 plus an minus 2 into n minus 2 x n minus 3 plus 8, because x to the power 0 is 1, and that is that. Very simple. We have just used the formula f of x is equal to xn, then f dash of x is equal to n x to the power n minus. We can take some more examples here. Example, we will say fx is equal to, let's suppose, 3x to the power 5. Now in that case, f dash of x will be nothing but 3 constant, will just keep it. 5 x to the power 5 will become 5 into x to the power. We just multiply this guy here and reduce the power of it. Correct? We can take one example. Example, fx is equal to, let's say, x to the power 11. So what will be f dash of x? This will become 11 will multiply here. So this will become 11 into x to the power 11 minus 1. That is 11 into x to the power 10. And that will be that. Correct? We can take one more example. Fx is equal to x to the power 7. So if you want to find f dash of x, what you do, you just multiply this, you take this down here, it becomes 7 into x to the power 7 minus 1 is 6. And that is next. Very simple. F of x is equal to x to the power n. So f dash of x is equal to n x to the power n minus 1. So this was our answer. We will practice this. We'll take one example. F of x is equal to 6 x to the power 100 minus x to the power 55 plus x. We have to find f dash of x. So we can do that. F dash of x. So here 6 constant will put like this only. X to the power 100. And to find the differentiation, so this becomes 100 will come down. So this becomes 100 into x to the power 100 minus 1. Correct? Minus x to the power 55. You differentiate. 55 will come down. 55 into x to the power 55 minus 1. Correct? Plus x to the power 1. This is x to the power 1 actually. This becomes 1 into x to the power 0. Correct? So what we get is 600 x to the power 99 minus 55 x to the power 54 plus 1. And that is the answer. Very simple. Here also what we have done, we have just used this formula. If f of x is equal to x to the power n, then f dash of x is nothing but n x to the power n minus 1. That is the formula we have used. We will take one more example. We have to find the derivative of this function fx 1 plus x square x cubed with x to the power 50 at x equal to 1. So first let's find f dash of x. Then we will put x equal to f dash of x. For constant value, if you differentiate, this becomes 0. For x, this was x to the power 1. So this becomes 1 into x to the power 1 minus 1, this is 0. Plus x square, this becomes 2 into x to the power 2 minus 1. Correct? 2 will put down. Plus x cube, this becomes 3 into x to the power 3 minus 1. x4, this becomes 4 into x to the power 4 minus 1. Dot dot dot. X to the power 50, this becomes 50 into x to the power 50 minus 1. So this becomes 0 plus 1 plus 2x plus 3x square plus 4x cubed dot 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 50 into x to the power 49. This is nothing but f dash of x. But we are supposed to find f dash of 1. So f dash of 1 is equal to, we'll put x equal to 1. 1 plus 2 into 1 is 2, plus 3 into 1 square, plus 4 into 1 cube, dash dash dash, 50 into 1 to the power 49. This is nothing but 1 plus 2 plus 3 plus 4 plus 5 dot 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 50. You see, this is the AP. So the answer will be 50 into 51 by 2. So for AP of natural numbers, it becomes n into n plus 1 by 2. So this becomes 1 to 7. And that is it. Very simple. What we have done, we have first to fx, we have found f dash of x, and then we have found f dash of 1. In this example, we have to find the derivative of x plus 1 by x. So we can write this in this form. F of x is nothing but x plus 1 by x. That is nothing but x by x plus 1 by x. Correct? That is nothing but you can say 1 plus 1 by x. Now if I want to find f dash of x, f dash of constant 1 is nothing but 0, and f dash of 1 by x is nothing but minus 1 by x square. We have seen that. Correct? Or we can also write f x to the power minus 1, because f of x equal to x to the power minus 1. You want to find f dash of x, this becomes minus 1 into x to the power minus 1 is minus 2. So this is minus 1 by x square. So our answer is f dash of x is nothing but minus 1 by x. And that is the answer. Very simple. What we have done, we have just factorized this and we have found the f dash of x. We can also assume that f of x is of this form, px by qx. Example, if you see this is of this form, x plus 1 by x. So we can assume that this is of the form fx is equal to px by qx, and then we can use the division principle to find the answer. But that will be a lengthy one, where we have to first differentiate px, then multiply qx, then minus differentiate qx multiply px by x square. You will get the same answer. Let's try this. So if you see that d by dx of px by qx, that is nothing but d by dx of px into qx minus d by dx of qx into px by qx square. Right? This is the value. Now here px is nothing but x plus 1. This value will be d by dx of x plus 1 minus into x, qx is equal to x, minus d by dx of qx, that is x, into x plus 1, and the whole thing divides by qx is x, so x square. This becomes d by dx of x plus 1 is nothing but 1 plus 0 into x, minus d by dx of x is nothing but 1 into x plus 1, correct, x square, and this comes out to be x minus 1 by x square, and that is minus 1 by. We see we got the same answer. So if you directly solve it, or if you use this formula px by qx, you got the same answer. But this was a lengthy one, so we thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.